Hello everyone. In today's class, we are going to learn IP LAQ questions particularly, that is on potentiometer. Okay. So this LAQ you are getting in exam for 8 marks. So these are the applications we can say particularly of potentiometer. So I am writing question and I am explaining likewise so that it will be easy for you to write in the exam. So what type of question they are asking? See here. Question is like this. State the working principle of potentiometer. State the working principle of potentiometer. Explain with the help of circuit diagram. Explain explain with the help of circuit diagram how the EMF of two primary cells, how the EMF of two primary cells are compared by using potentiometer. Okay, this is what the question they are asking. Below this you may get one problem also. That problem I will explain later. First this one we will finish. Okay, so read question first. What he is asking in the question, he is asking you first you have to state working principle, and then we have to compare EMF of two primary cells using the potentiometer. This is what he is asking about, and also with circuit diagram. So first I am writing principle. What is the principle of this potentiometer? So the principle of this potentiometer is, I am writing like this: potential difference, the potential difference across the length of the potentiometer wire, across the length of potentiometer wire is directly proportional to its length. Potentiometer wire is directly proportional to its length. Okay, right? The potential difference across the length of potentiometer wire is directly proportional to its length, and that is nothing but, can I write like here, that is E is direct proportional to L, and therefore E is equal to phi into L. What is phi here? Phi is potential drop per unit length. Potential drop per unit length. Okay. The potential difference across the length of potentiometer wire is directly proportional to its length. This is what your principle. In bracket you can write assuming steady current and uniform area of cross section of wire. Understand? What is that? Means whatever the wire is there, it should be of same area of cross section. Means if suppose this is a wire, so this should be like this only. Otherwise here it is like this, then it become little big in between only, and then again it become more big. So this is not allowed. So wire should be uniform. Understand? And current should flow constant only. Otherwise here it is I, here it is 2I, and here it is 3I, then it is not allowed. Understand? So that's why assuming steady current and uniform area of cross section, we can say, that is what, then only the potential difference across the wire is directly proportional to its length. And this is what your working principle of the potentiometer. Yes, understand? Now next, so this finished our principle. Next, let's draw the diagram. So first circuit diagram I am drawing, right? So I am writing here circuit diagram. Yes, circuit diagram. So how to draw the diagram for this potentiometer? I think I will draw on the next page because it requires some space. So you keep this circuit diagram heading and let's go on next page. First note down this part. Okay. So heading you write here comparison of EMF of two cells. So this is what comparison means. This circuit diagram is for what? Comparison of EMF of two cells. EMF of two cells E1 and E2. Okay. So let's draw the diagram. How to draw? Concentrate. See here how I am drawing. First you take one straight line that is horizontal. Okay. Then from this you come little down. Then again another parallel line. Okay. Then again from this little down. Again another parallel line. Again little down. Again one more parallel line like this. Again little down. And again one more like this line. Okay. And then from this point you can join this line like this. Okay. Next, after this, select one point on this line here. This is a point, and from this you have to connect cells. So take here like this because you are going to connect two cells for comparison. So here is one, and this is another cell which we are going to connect now, like this. Okay. So here is cell E1 and here is cell E2. Like these two cells we have connected, and then this whole thing we have connected to a key arrangement like this. Like this key is there, and then from this we are connecting galvanometer. Okay, this is what your galvanometer is, and you are getting null points over here. One null point due to cell E1, another null point is due to cell E2. Okay, this is N1 and this one is N2. And now this side you connect primary cell or primary circuit, we can say. Across this you can connect one battery, then here is a rheostat across this, and you can connect one key also here. Okay, so let's draw it. So here is a high voltage battery. This is positive terminal, negative terminal, positive terminal, and again here it is negative terminal. This is your rheostat. Rheostat, you know, rheostat is what? Variable resistance. And this is your key which we have connected. Key, here it is rheostat. This is K, this is R, and this is battery. Okay, give some points. This is point A. This cell is cell E1. This one is cell E2. This point is 1, this point is 2, and this one is 3. So let's see now. So first point, you understood the diagram, how to draw. You can draw this diagram. So see here, first point what I am doing or writing. So first, because we have to draw the circuit for comparison of EMF of two cells. So first point you write about that only. To compare the EMF of two cells, to compare EMF of two cells of EMF E1 and E2 of EMF E1 and E2 of EMF E1 and E2 with potentiometer is as shown in figure. है ना, देखो कैसे होता है, you can see in the figure. This is your first point you have to write. Next one. So this one, a two-way key is connected or you write like this: the points marked 1 comma 2 comma 3 form a two-way key. Two-way key means what? Two-way key means one time one will get contact, or one cell will be in a contact, second time you will get another cell in a contact. How? You see here, I will show you that. If suppose this 1 and 3 are in contact, then only circuit current, or through this secondary circuit whatever the current is flowing, that is because of this cell. When these 2 and 3 are in contact, then only circuit current is because of this E2. Understood? Right? Like that. Let's move ahead now. So now see what I am writing next point. If 1 comma 3 are in contact, we will get null point n1 at length L1 due to cell EMF E1, isn't it right? Cell EMF, you can write like this also. Cell EMF E1. See in the diagram, when this is in contact, you see I will use the color. So first I am using red color. You can see this is the red color. So first this is in condition, or this is in contact 1 and 3. So when this 1 and 3 is in contact, this is open. So whatever the current is flowing, this is because of this cell, and hence we are getting null point N1 because of cell EMF E1. And therefore, can I write like this? Therefore, E1 is equal to phi L1, because already we have learned potentiometer principle. What is that? E is proportional to L, and therefore here you are getting E1 is equal to phi L1. Okay, next point. Now this time I am changing color again. I am taking, let's take yellow. So when next time these 2 and 3 are in contact, you can see this 2 and 3 in contact. Can you see? So if 2 and 3 are in contact, so I will write with yellow only here. If 2 comma 3 are in contact, what happens? We will get null point N2 at length L2 due to cell EMF E2. Okay, cell EMF E2. So here what we are getting then? Therefore, E2 is equal to phi L2. Call this equation number 2. What is this null point, sir? Null point means when we are sliding jockey over this wire. Okay, we will do experiment meter bridge. That time you will understand what is jockey and how we are getting null point. So getting null point means this galvanometer is there, no, it will show zero deflection. When it is showing zero deflection, that is called null point. And when we are riding the jockey over this wire like this, at particular point galvanometer will show null deflection. It means what? Bridge is balanced. Very simple. Bridge is balanced, and that's what you are getting null point. So E2 is equal to phi L2. Now see here, from equation 1 and 2, from equation 1 and 2, can I divide this? So see here, E1 by E2 is equal to phi L1 divided by phi L2. So this phi and this phi will get cancelled, and hence how you will compare the length, or how, what you can say, how you will compare the EMF direct you will get E1 by E2 is equal to L1 by L2, and you can keep this in the box. Okay, this is what your required answer is. So in terms of length you will get the comparison of EMF. Okay, so note down this. Okay, note down, try to understand and note down. Okay, so let's move ahead again. Now let's see one problem on this model. What type of problem they are asking? You can see here the problem. So see here how they are asking problem. In a potentiometer arrangement, in a very easy, actually you can do very fast. In a potentiometer arrangement, a cell of EMF, a cell of EMF 1.25 volt gives a balance point, gives a balance point at 35 centimeter, at 35 centimeter length of wire, length of wire. If the cell is replaced, if the cell is replaced by another cell, if the cell is replaced by another cell and the balance point shifts to 63 centimeter, what is the EMF of the second cell? What is the EMF of second cell? You see, if you will observe, this is very easy question, right? And this is looking just a big question, but it is very easy. So let's see what is given things here. You can do it yourself. Given E1 is equal to 1.25 volt. Next, L1 is equal to 35 centimeter. E2 they don't give. E2 is equal to question mark. And L2 is how much? 63 centimeter. So now you see how much easy this is. E1 by E2 is equal to L1 by L2. Substitute the values and do it yourself. Okay, do it yourself. Answer I am giving you. E2 is equal to 2.25 volt. Okay, note down the question and solve it yourself. Okay, next. You can solve like this more questions if you have in a question bank. If you have more questions, you can solve your own on this model. Not an issue. Okay. So let's move ahead. And now next one is another potentiometer. Yes, that is what another potentiometer we are using for measuring the internal resistance of the cell. Okay, so see here, question is how they are asking for this. Another question, state the working principle, state the working principle of potentiometer explain with the help of circuit diagram. Explain with the help of circuit diagram how the potentiometer is used, how the potentiometer used to determine the interresistance of the given primary cell. To determine internal resistance of given primary cell. Okay, so what is the question? See, state the working principle of potentiometer, explain with the help of circuit diagram how the potentiometer used to determine interresistance of the given primary cell. Means here now we have to draw the circuit to determine interresistance of a cell. So first of all, he is asking here also what is the working principle. So you have to write principle. Okay. So if you will see backside, same principle as it is you note down. Same as it is still here. Okay. Same this you write down because working principle is same. So therefore you will write here as it is. Which one? This working principle which you have written above, this one. Okay, 1 2 3 lines till here. Understand this part, you note down as it is. Okay, next one. So you note down yourself, same as above. Okay, don't write in exam same as above. Okay, write down same as above means what? So you write down, or else if you want, shall I write? Okay, so what is the working principle? The potential difference across the length of potential wire. I will write, otherwise in exam also sometimes you will write like that only, same as above. Oh, sir wrote in notebook like that only, so we are also writing like that only. So this is not good, right? The potential difference across the length of the potentiometer wire, potential difference across length of wire is directly proportional potential difference across the length of the potentiometer wire बोलेंगे. Okay, what we will say, potential difference across the length of potentiometer wire, across the length of potentiometer wire is directly proportional to its length, है ना? Same like previous one. Yes. So here it is what? Assuming constant current and uniform area of cross section of wire. So that is E is proportional to L, and therefore E is equal to phi L, and where phi is what? Potential drop per unit length. Is it clear? Understand now? Okay. Right. So let's draw the diagram now. On next page I am drawing. So on next page, let's see how is the circuit diagram for this one. So circuit diagram. In this also, you are having almost same circuit diagram, but just little change is there. So what is that? Let's see. I'm leaving little space ahead. Okay. So next one, again coming down from here, and then again joining this. This is same like previous one, just a circuit, little difference is there in the circuit. Okay. So again, I am selecting one point here, and from this point, we are going to connect a secondary circuit. So here is what, a key and one resistance box I am connecting now. And here we are having a cell, because only one cell we are connecting here, only one cell. And then you can connect these two, and from these 2 points we are going to connect galvanometer wire. This is a galvanometer, and here again you are getting null point 1, and here it is another null point. This is N1, this one is N2. So this is resistance box, this is K1, and this is cell EMF E. And this side same thing as usual, battery, then rheostat, and then one small key. This is primary circuit. Yes or not? Here it is a battery. Then here as usual resistance, that is rheostat, variable resistance, and here is a key. So this is I am denoting with K because I have denoted here K1, and this is R, and this is battery B. So did you understand circuit? Same thing, nothing changed. Just here this side we have changed. You can see here instead of cell you connect one key and resistance box. So let's start doing now, or first points we will write. To determine internal resistance of a cell, circuit is as shown above. That's it. First point finished. Next point, what you have to write. Let's start now. So I am writing one point about this arrangement. So can I write like this? See, the cell of EMF E, whose internal resistance whose internal resistance R is to be determined you see the diagram, is connected across the resistance box, across a resistance box RB through key K1, through key K1. यहाँ पे देखो, can you see here? This is a cell which we have connected across this K1 and this resistance box. Now see, next point see. Now when this K1 is open, what is the case? When this K1 is open, this is not in the circuit, then only current is flowing through this, right? And we are getting 0.N1. So see, when K1 is open, we will get null point N1, null point N1 है ना, at length L1, yes or not? Null point N1 at length L1 due to cell EMF E. So therefore, what I should write, E is equal to phi L1. Call this equation number 1. Okay. So first note down this, draw the diagram and note down fast. Okay, finished? Okay, finished? So next point, see now, when K1 is closed, what happens? When K1 is closed, then cell sends current through resistance box R, है ना? Because see here, when this is a closed, current will flow through this also. Cell sends current I through resistance box. So this is RB. Therefore, if phi is terminal potential, then due to this potential, we will get null point n2 at length L2, है ना? Because see, when this K1 is closed, current will flow through this also, and therefore terminal potential is changing phi, because not here E. Why? Because this is not because of only cell. Because of this resistance, you are getting some drop. Got it? So therefore, can I write like this? Phi is equal to phi L2. So let's call this as equation number 2. Already one finished, no? You make it here 2. Equation number 2. What is that? P is equal to phi L2. Now from equation 1 and 2, from 1 and 2, what you are getting? E by V is equal to phi L1 divided by phi L2. This phi will get cancelled, and you are getting E by V is equal to L1 by L2. Okay, up to this we understand. But we know what we know. I is equal to E divided by R plus R. Therefore, E is equal to, in cell we have learned, no? In cell, total current through cell is what? Cell EMF divided by internal resistance plus external resistance. Therefore, E is equal to I into R plus small r. And V is equal to what we are having? I into R. है ना? Therefore, substitute these values, substituting in equation 3 बोलेंगे इसको, है ना? In equation 3, what we are getting? C. E is what? I into R plus small r divided by I into R is equal to L1 by L2. This I and this I will get cancelled, separate denominator. So what we are getting? Next step after this, I am separating the denominator. So this is R by R plus small r by capital R is equal to L1 by L2. This is 1. So 1 plus small r by capital R is equal to L1 by L2. So that implies, again, I am transferring this 1 this side. So what I am getting? R by capital R is equal to L1 by L2 minus 1. And therefore, R is equal to L1 by L2 minus 1. And this capital R is going here in a multiplication. So if you want more, you can simplify this. This is L1 minus L2 divided by L2 into this is R, and hence what? This is what your internal resistance of the cell formula which you are getting. Is that clear? Understood? So note down this, do it yourself, very easy. Note down fast. Note down. Note down fast. On this model, I am sending you one question. You can solve yourself. I will send you a photo. Okay. On this model, you solve this problem. Okay. So let's stop here for today. Enjoy the day and revise properly. These are very important LAQ questions. Bye.